Composition of trig and inverse trig. So in this particular video, I want to point out that I am talking about trig and inverse trig when the functions don't match. So this is cosine inverse and cosecant, tangent and sine inverse. I have a whole other video that will be about composition of trig functions with its own inverse, like sine of sine inverse or sine inverse of sine. But that's for later. So this is with the trig functions that vary. And there's two different things that can happen here. Either you can have the inverse be on the outside. So you can see right here, the inverse is on the outside. Inverse on the outside. Or we can have the inverse on the inside. And those situations are handled differently. They are similar, but they are different processes, and one is a lot more lengthy than the other, as you can see by steps 1, 2, and 3 for the second one. It will start with inverse on the outside. So if you have the inverse on the outside, like we have here or down here, sine inverse of cosine of 7 pi over 3, the whole idea is to work from the inside out. Work from the inside out. Ooh. My pen is being funny. There we go. Work from the inside out. So you start with this very centerpiece right here. Cosine of 7 pi over 6. And you simplify that piece first. So cosine of 7 pi over 6, that's going to be the x value at 7 pi over 6. Let's see, I can scroll, I think. Where did I put the nearest one? Down here. So cosine of 7 pi over 6, the x value at 7 pi over 6 is negative square root of 3 over 2. Because these two things are equal, anywhere I see cosine of 7 pi over 6, I can put a negative 3 over 2 instead. So I can rewrite this function as sine inverse of negative square root 3 over 2. Maybe I'll do that arrow from here. That's a lot messier. There. And now the question is, what is sine inverse of negative square root 3 over 2? Well, we can do our little circle. And sine inverse has the range from negative pi over 2 to pi over 2. You cannot write this down too much. You cannot write it down too enough. You should write it a million times. Write the ranges out and also write out, I haven't done it yet in this video, inverse trig outputs an angle. If I had my way, you'd be having nightmares of me saying this. Maybe not nightmares, dreams. Where I say inverse trig outputs an angle because it's so incredibly important. The output from this is going to be an angle. We know we're going to be looking down here in quadrant 4 because this is a negative value. So we're asking ourselves between negative pi over 2 and pi over 2, where is the y value? Negative square root 3 over 2. And we had relabeled our circle up here. So where is it? Well, there's the y value, negative square root 3 over 2, and it's at negative pi over 3. I had to take a moment there because I had the wrong answer written in my own notes, and I had to figure out if past me was wrong or future me was wrong. And no, the answer is indeed negative pi over 3. Negative pi over 3. Boom. So when the inverse is on the outside, it's just figure out what the inside is. Then it reduces it down to just an inverse problem. Wham, bam, thank you, ma'am, you're done. When the inverse is on the inside, it's a little bit trickier of a situation, but you're going to run into a trick that you're going to use over and over and over and over and over again. And it's set inverse trig equal to theta. Then rewrite as regular trig. So cosine of sine inverse of negative 7 over 25. We start. I'm just going to write this sine inverse of negative 7 over 25. This piece right in here, we set this whole thing equal to theta. So sine inverse of negative 7 over 25 is equal to theta. This does a few things for us. First of all, anywhere I see sine inverse of negative 7 over 25, I can replace it with a theta. So this whole thing right here is a theta, which means what we're really looking for is cosine of theta. What we need is cosine of theta. This is one way of writing it. But if sine inverse of negative 7 over 25 is theta, what is equally true, what must be equally true, is that sine of theta must be negative 7 over 25. Right? It makes sense, right? If we're saying, hey, here's an angle that spits out this y value. If you're looking at this y value, here's an angle that gives it to you. Then, of course, when you put that angle in, that y value is going to come out. So you're just rewriting it in a different way. Some people like to look at this as taking sine on both sides and having these signs cancel. And this totally works. This totally works for the case we're using it for here with this composition. We'll talk more about cancellation rules in the video after next. So that's one way you can think about it. You can think about it. That would leave you with negative 7 over 25 is equal to sine theta. Or you just think about it as rewriting it. All right. So we know that sine of theta is equal to negative 7 over 25. I'm going to circle it because that's one piece of information we need. The next part is deciding which quadrant it's in by theta is in by using the range of the inverse trig and the information we were given in step 1. So we know that theta came from sine inverse, right? That's where we got theta from. We set sine inverse equal to theta. So theta came from sine inverse, which means theta can only be in quadrant 1 or 4. Theta must be between negative pi over 2 and pi over 2. Right? It can only be in these two quadrants. So get rid of these two. It can't be in these. And we know that sine of theta is negative because it's equal to negative 7 over 25. So if sine is negative, remember all students take calculus. If sine is negative, we surely can't be in quadrant 1. So this has to be from quadrant 4. Quadrant 4. So here it is all together. The question we're really being asked is, dun, 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 the same question we've answered 1.5 million times, the same types of questions you answered all last chapter. if sine of theta is equal to -7/25 and theta is in quadrant 4, what is cosine of theta? And you've done this a million times. So in quadrant 4, cosine is positive. So I know my answer, cosine of theta. I know it's going to be positive. For the triangle, SOHCAHTOA, I know sine is opposite over hypotenuse. So opposite is 7, hypotenuse is 25. I don't deal with those negative signs. So there are ways of doing it. I know Alex teaches it a particular way where you use negatives as side lengths on triangles. I don't like having triangles with negative side lengths, so I don't do that. I just take care of the signs right away. So the opposite side is 7. The hypotenuse is 25. And if you do the math down here on this missing side, it comes out to 24. And that's by doing square root of 25 squared minus 7 squared. It gives you 24. Cosine is adjacent over hypotenuse. So katoa. The adjacent side, label these here. Here's the opposite. Here's the adjacent. Here's the hypotenuse. So the adjacent side is 24. The hypotenuse is 25. So cosine of theta is equal to positive 24/25. I'm going to get rid of the positive sign because we don't really need that. And that's our answer. It's really more than that, though. What we're really saying is that cosine inverse, or not cosine of sine inverse of -7/25 is 24/25. We just said that this whole thing was theta, so we could simplify it that way. But that's how these ones go. So let's do a few more examples. All right, this first one, secant of arctan of -6. I'm going to rewrite this the way I like to see it, which is secant of tan inverse of -6. And this is equal to theta, not equal to theta. Whoop. This guy is a tangent inverse. So there's an inverse on the inside. We're calling this guy theta. Tan inverse of -6 is equal to theta, which means what we're looking for is secant of theta. Well, secant of theta. We can rewrite tangent inverse of -6 is equal to theta as tangent of theta is equal to -6. I like to think of this as -6/1. Remember our toa. So this is opposite. This is an adjacent. We're going to do an all students take calculus to figure out what quadrant we're in. This is tangent inverse. Tangent inverse's range is -π/2 to π/2. That's the range of tan inverse. So we know we're not in quadrants 2 or 4, or not 2 or 3. We know tangent is negative, so it can't be in the first quadrant. This has to be in quadrant 4. All students take calculus. And again, the reason we have to strike out quadrant 1 is because tangent is negative. All right, so we're in quadrant 4, and we know we're looking for secant of theta, secant's soulmate, secant of theta, soulmate is cosine of theta. So if cosine of theta is positive, secant of theta will be positive. And indeed, cosine is positive, which means secant is positive. And we're looking for secant of theta. So secant of theta is, I'm going to make a note that it's positive, so at least I know I've done that. And now I've made myself no room to make a triangle. That's okay, we can be creative here. Here's theta. Opposite side will be 6, adjacent side will be 1. This will be square root of 37. We have the hypotenuse, the adjacent. I can like zoom in further here. The adjacent, the opposite. If cosine is adjacent over hypotenuse, that means that secant is hypotenuse over adjacent, the flippity flop, because they are soulmates. Hypotenuse is square root of 37. And, oh no. Oh yeah, we're good. Square root of 37 is the hypotenuse, adjacent is 1. So really, this is just square root of 37. That's our answer. I'm writing down a lot of work here as well. When you're doing these, they can go a lot faster when you're not writing down every last detail. All right, cotangent of cosine inverse of -2/5. This is a cosine inverse on the inside situation, so I'm going to take that inverse and set it equal to theta. So theta is equal to cosine inverse of -2/5. That means cosine of theta is -2/5. So if we're circling important information, this is a piece of important information. Let me move this circle a little bit. Cosine inverse's range is 0 to pi. So we know that this angle is not going to be in quadrants 3 or 4. Cosine is negative, so it can't be in quadrant 1. All students take calculus. So we are left with quadrant 2. So we know that cosine of theta is -2/5. Theta is in quadrant 2. We said that this whole thing was theta, so what we're looking for is cotangent of theta. And we've now simplified the problem. We're saying if cosine of theta is -2/5 and theta is in quadrant 2, what is cotangent of theta? I'll make a note down here. Tangent, TOA, is opposite over adjacent. Soulmate is cotan, so cotan of theta should be adjacent over opposite. I'm making that note. That'll come in handy. Making a triangle. Cotan of theta in quadrant 2, tangent is negative, so cotangent's negative, so I'm putting a negative down first. Cosine is adjacent over hypotenuse. So 2, again, I'm leaving off the negatives because I've already taken care of it. 2, and oops, 5 doesn't go there. 5 goes here. And this side over here becomes square root of 21. Oh, goodness me. Opposite, adjacent, hypotenuse. Cotangent of theta is adjacent over opposite. So that's 2 over square root 21. And there's a negative already there for us. And that's our answer. All right. These next two are with the inverse on the outside. So I will rewrite this because I like to see it as cosine inverse. Cosine inverse of sine of 5 pi over 4. We'll start by resolving the sine of 5 pi over 4. This is just work from the inside out. So what is the y value at 5 pi over 4? Here's 5 pi over 4. The y value is negative square root 2 over 2. So cosine inverse of negative square root 2 over 2 cosine inverse's range is from 0 to pi. If my dog starts barking, I am sorry. He just heard a noise. He knows better. So between 0 and pi, where is the x value? Negative square root 2 over 2. And honestly, you can't write this enough. Write these things down. Write exactly what it is that you're finding down so that when you look back at your own notes, you're able to see and make these connections. What angle theta between 0 and pi gives an x value of negative square root 2 over 2, right? You're looking at these guys. Where's the x value? Negative square root 2 over 2. That is here at 3 pi over 4. And that is our answer. So we started by saying, okay, sine of 5 pi over 4 is negative square root 2 over 2. When I plug that back in, I'm just looking for cosine inverse of negative square root 2 over 2. That's at 3 pi over 4. Last one here. We have tan inverse of sine of 3 pi over 2. Again, resolve the inside first. Sine of 3 pi over 2. That's the y value at 3 pi over 2. So 3 pi over 2, let me use a different color. 3 pi over 2, the y value is negative 1. Sine of 3 pi over 2 is negative 1. So now we're looking for tan inverse of negative 1. Which is saying where is tangent negative 1 between, and for tangent, that's negative pi over 2 to pi over 2. So let's go back up to our tangent. Let's see, did we do tangent up here? Here's our tangent. Where is tangent -1? And it's right down here. Tangent was in purple at -π/4. That was back in a previous video. Whoa, where are we? Here we are. And that's our answer. So they're a lot more straightforward when it's the inverse on the outside. But they're not undoable the other way. It's just you have to set up your triangle, do your all students take calculus, and do your SOHCAHTOA to get your final answer. All right, so that's it for composition with numbers. In the next video, we're going to talk about situations where it's an algebraic expression and what we do then. I'll see you in that video. Bye.